In this video, we're going to be looking at geometric translations. A translation slides an object a fixed distance in a given direction. The original object and the translation have the same shape, and they also have the same size. Okay, they will also face in the same direction. Okay, this means that the orientation of the shape is preserved, meaning that the order of the letters is the same. A translation creates a figure that is congruent with the original figure. Okay, the image will be congruent to the pre-image, meaning that that a translation is an example of a rigid motion. Okay, rigid motions create images that are congruent to their pre-images. In example number 1, we're going to practice translating a point. The point that we're going to translate is point P, which is located at -2, -1, found right here on our graph. I want you to write the coordinates of the image of point P after each translation and describe it below. Or, rather, I want you to write the coordinates of the image point P prime after each translation described right here below. So here's our pre-image. Okay, it's found at -2, 1 in each case. And the first translation that we're going to do, we're going to move it up 4 units. So here's our first point, or point P, -2, 1. I'm just going to move it straight up 4 units. 1, 2, 3, 4. Okay, if that were point P prime, where would it be located? Well, this would be located at -2, 3. -2, 3 is where that point would be located. But what if I took point P and I moved it down 2 units? 1, 2. Where would that be located? Well, that would be located at -2, -3, -2, -3. Okay, so summarize what we have just seen so far. A translation that moves up or down changes the blank coordinate of the point. Well, an up or a down translation. Here was our pre-image at -2, -1, and the image was at -2, 3 or -2, -3. Notice that the x-coordinate stayed the same, but it was the y-coordinate that changed. An up-down translation changes the y-coordinate, and that makes sense because if we have our y-axis right here, okay, the y-axis moves vertically, okay? And so any translation that we do up or down is going to change the y-coordinate. So an up-down translation changes the y-coordinate of the point. Now, what if we took our point P and moved it right or left? So again, point P is at -2, -1 right here. Let's first move it right 5 units. 1, 2, 3, 4, 5. If this were where point P prime were located, it would be at the point -3, or excuse me, +3, -1. 3, -1. What if I took point P and I moved it left 4 units? 1, 2, 3, 4. That would be found here at the point -6, -1. Okay, so what happened with a right-left translation? Well, again, here's your right-left translation. Our original point P, -2, -1, was moved to either 3, -1 or -6, -1. Notice that this time the y-coordinate stayed the same, and it was the x-coordinate that changed. A right-left translation changes the x-coordinate of a point. And again, that makes sense because our axis moves horizontally left or right. So anytime that you're going to translate a point left or right, you're going to have to change the x-coordinate of the point. In our next example, we're going to use what we learned in our previous example to predict coordinates of a point when it's translated horizontally, meaning left or right. Okay, so remember that a left-right translation is going to change the x-coordinate because the x-axis is what moves right or left on your graph. All right, so in this first example, we took some point at -2, 3, and we moved it right 7 units. Okay, so moving it right 7 units is going to change the x-coordinate, and we're going to take the old one and add 7 to it. the y-coordinate stays the same. So negative 2 plus 7 is 5, and 3 stayed the same. So translating negative 2, 3 to the right 7 units would put it at 5, 3. What if we took the point negative 2, 3 and moved it left 4 units? Well, again, your y-coordinate of 3 is going to remain unchanged because the point did not translate vertically up or down. But since it moved left 4 units, we're going to take the previous x-coordinate, negative 2, and we're going to subtract 4 from that because it's going to the left. All right, well, negative 2 minus 4 is negative 6, comma 3 is where negative 2, 3 would translate if we moved it 4 units to the left. What if we took the point 25, negative 10 and moved it to the right 8 units? Where will point P prime be? Well, remember, a right 8 translation is going to take the previous x-coordinate of 25 and add 8 to it. The y-coordinate, though, isn't going to change. That's still going to be a negative 10. So the new coordinate, point P prime, would be located at 25 plus 8 is 33, comma, negative 10. If we took some point, any point x comma y, and moved it to the right 10 units, all right, well, again, the x-coordinate is going to change by adding 10 to it. So x plus 10, comma, the y-coordinate isn't going to change when you move a point to the right. Similarly, if we took some point xy and moved it to the left 6 units, what we're going to do, again, is take the x-coordinate and we would subtract 6 from it, but the y-coordinate would remain unchanged. So moving left, you're going to do x minus 6, comma, y. Summarize what happened to your x-coordinate and your y-coordinate if we translate a point right or left by n units. Well, this means then that the x-coordinate will increase, n units if translated to the right. Okay, we saw up above that when we were moving an image to the right, we took the previous x-coordinate and simply added to it. All right, so add 7, add 8, add 10. The x-coordinate will increase n units if translated right. The x-coordinate will decrease n units. It will decrease n units if the point is translated to the left. If the point is translated left. Okay, so when we moved a point to the left a certain number of units, we took the previous x and we subtracted from it. Okay, so moving to the x, you're going to decrease the x-coordinate by n units. All right, but remember, in all cases, your y-coordinate is unchanged. The y-coordinate is unchanged if you are translating right or left. And again, because the y-axis moves vertically, all right, so that means that the y-coordinate will be unchanged if you're translating a point to the right or to the left. We just translated points horizontally, and now let's see what happens when we translate our points vertically, okay? So let's see what's going to happen here. This should actually say that we're translating vertically, which will mean up or down. Okay, so remember, vertically is going to change your y-coordinate. Your x-coordinate will be unchanged because the x-coordinate moves horizontally. So if I wanted to translate a point up 4 units, if my point was negative 2 comma 3, I'm going to leave the x-coordinate alone, but I'm going to take the y-coordinate and I'm going to add 4 to it since we're translating up, 3 plus 4. All right, well, 3 plus 4 is 7, so that means that this point translated up 4 units would move to negative 2 comma 7. Again, the x-coordinate stayed exactly the same, but the y-coordinate, we added 4 units to it. What if we took the point 25, negative 10 and moved it down 5 units? Well, again, your x-coordinate isn't going to change, but your y-coordinate, we're going to take that, so negative 10, and since we're moving down 5, we're going to subtract 5, meaning that the point P prime would be located at 25, comma, negative 15. If I took any random point x comma y and I moved it up 7 units, the x-coordinate will be unchanged, but your y-coordinate, since we're moving it up, will have to add 7 units to it. If you took some point xy and you moved it down 12 units, again, your x-coordinate is unchanged, but since we're moving down 12, your y-coordinate is going to decrease by 12, y minus 12. So summarize what happens when you move a point up or down, when you translate vertically up or down n units. Well, again, any translation vertically means that the x-coordinate will be unchanged. The x-coordinate is unchanged if translating up or down. All right, the x-coordinate is unchanged if translating up or down. But the y-coordinate could change two different ways. All right, one way, the y-coordinate increases n units. The y-coordinate increases n units if translating straight up. If translating up. So when you add, or excuse me, when you move a point up, all right, you're going to add that value to your previous y-coordinate. All right, the y-coordinate increases n units if translating up. Similarly, the y-coordinate decreases n units. The y-coordinate decreases n units if you are translating straight down. All right, if you are translating down, decrease the y-coordinate n units. So here I was moving it down 5, I took the previous y and subtracted 5. Here we're going down 12, take the y value and subtract 12 from it. In our next example, we're going to combine horizontal and vertical translations. These combined translations can be described using an algebraic rule or a verbal rule, and we're also going to write the translation notation. All right, the translation notation uses a capital T for translation, and then a little point here, x comma y, that's going to describe how the point is moving either horizontally for the x or vertically for the y. Okay, so this notation is used to describe a translation. What we're going to do, we're going to fill in the missing rule, all right, either the algebraic rule, the verbal rule, or the notation. And the first one was done for us. So the algebraic rule, we took our point, our pre-image x comma y, we subtracted 3 from x, and we added 5 to y. When you subtract 3 from x, that means you're moving the point 3 units to the left. And when you add 5 to the y value, you're moving the point up 5 units. So x minus 3, y plus 5, we're moving left 3 and then up 5. The notation rule for that, capital T, and then negative 3 comma 5, meaning that we're going to subtract 3 from the x-coordinate, add 5 to the y-coordinate. In this middle example, the verbal rule was given to us. We're going to move right 2 and then down 4 units. Okay, so if you move right 2 units, what you need to do algebraically is take your x-coordinate and add 2. Then if you move down 4 units, you take your y-coordinate and subtract 4 since you're moving down. All right. Notation wise, moving right 2 and down 4 means that T for translation, it's going to move positive 2 for the x coordinates, negative 4 for the y coordinates. So T and then 2 comma negative 4 when we write the translation notation. All right. In this example, the algebraic rule was done for us. We need the verbal rule and the notation. Notice here, algebraically, that your x-coordinate did not change at all. So your point is not moving horizontally to the left or to the right. But you're adding 3 to your y-coordinate, which means you're moving vertically up 3 units. So we're moving up 3 units with our point. For our translation notation, we've got the capital T for translation. And then for the little coordinate here, since the x value was unchanged, we're not moving it at all, so we're going to put a 0. But for the y coordinate, since we added 3, we're going to put a positive 3. All right, t 0, comma 3 means that we're moving this not at all horizontally, but up 3 vertically. Our verbal rule for this example, we're moving to the left 5 units. Moving left is going to change your x coordinate, and since it's going to the left, we're going to have to subtract 5. So we're going to do x minus 5 for the x coordinate. And then since we're not moving up or down, your y coordinate is going to stay exactly the same. So x minus 5 comma y means that we're moving left 5 units. And for our translation notation, there's our capital T. And then our x coordinate, we're going to subtract 5, so negative 5. Our y coordinate isn't going to change, so that'll be a 0. T and then negative 5, 0 is the notation for that type of a translation. In our next examples, we're going to see how our shapes are translated on the coordinate plane. Okay, remember that your pre-image is going to be the original letters A, B, C or A, B, C, D, but your images are going to have the prime notation. So you're always moving from the pre-image to the image. And if we look at our first example here, we have triangle ABC, that's the pre-image, and the image is triangle A prime, B prime, C prime. I want to know, how did you move from the pre-image ABC to the image A prime, B prime, C prime? Okay, so this was a translation, right? We slid this triangle down here. All right, how did we do that? What is the verbal rule? What's the algebraic rule? What is our translation notation going to look like for this example? Okay, well, in order to figure that out, you just have to figure out how each point maps to its image point. Right? How does A go to A prime? How does B go to B prime? How does C go to C prime? Now, the nice thing is that all of these letters move the same way. Okay, so however A moves to A prime, it's the same as B to B prime and C to C prime. So pick one of them to use as your example. All right, I'm going to go ahead and use point B and see how it maps to point B prime. Remember that with a translation, you're going to be moving horizontally first, and then you're going to be moving vertically. So here's point B. I have to first move it horizontally until it's straight above point B prime. All right, so I'm going to move point B 1, 2, 3, 4 units to the right. Okay, 1, 2, 3, 4 units to the right. So that means we're going verbally to move right 4. And when we move right 4, we take our x coordinate and we add 4 to it. Now, I have to figure out how I'm going to move vertically until I reach point B prime. Okay, so if I move right 4 units, point B is here. Now I have to move down 1, 2, 3 units. Down 3 units. All right, moving down 3 takes the y coordinate and subtracts 3 from it. Okay, so for the translation notation, we have our capital T for translation. And then for our little point here in parentheses, we're adding 4 to x, so positive 4. And then we're subtracting 3 from y, negative 3. T 4 comma 3. All right, so that means you're moving right 4, down 3. Do it with point C. 1, 2, 3, 4 to the right. 1, 2, 3 down, get you to C prime. With point A, 1, 2, 3, 4 to the right, 1, 2, 3 down, get you to point A prime. How about in our example B? This time we have a trapezoid, ABCD, and its image, A prime, B prime, C prime, D prime. So this is the pre-image, ABCD, and this is the image, A prime, B prime, C prime, D prime. How did this trapezoid translate or slide over to this trapezoid? Okay, so we're going to give our verbal rule, our algebraic rule, and the translation notation. Now, the nice thing about this one, all right, if you just pick any random point, let's use A to A prime. Notice that these are already on the same line here on the x-axis, okay, whatever line this is, meaning that I don't have to move my point vertically at all right? A lines up with A prime along this horizontal line here. So I know that my Y coordinate isn't going to change at all. I'm not going to have to move vertically up or down. So I'm just going to, at the end here, put a Y because my Y coordinate isn't going to change at all. But to get from A to A prime, I'm going to have to move to the left 1, 2, 3, 4, 5, 6, 7, 8 units. We moved left 8 units. And moving left 8 units takes your X coordinate and subtracts 8. Okay, so again, if I move left 8 units, 1, 2, 3, 4, 5, 6, 7, 8, I'm already at my point A prime. And again, I don't have to move vertically at all, which is why the Y coordinate is unchanged. For the notation, capital T, and then X we subtracted 8, so negative 8, comma, Y stayed the same, so that's going to be a 0. That is the translation notation for this example. Now that we've reviewed the verbal rule, algebraic rule, and the translation notation, we're actually going to do the translation ourselves. So we have a blank coordinate plane here. The first thing we're going to do is plot the vertices of a rectangle ABCD. Point A is at 6, negative 4, so I'm going to move to the right 6 and down 4. There's point A. All right, point B is going to be located at 6, negative 6, so I'm going to go to the right 6 and down 6 right here. And then point C is at 2, negative 6, 1, 2, and then down 6. Right here is point C. And then point D is at 2, negative 4, to the right 2, and down 4 right here. There is point D. And let's use our ruler to connect those points. Okay, so this is going to help us to visualize rectangle ABCD. And one more line. There we go. There is our rectangle ABCD. Okay. What we're going to do is use the algebraic rule x minus 5, y plus 7 to translate each of these original points from our pre-image. Okay. Predict how the rectangle will be transformed with this rule, x minus 5, y plus 7. Well, this is going to be a translation. And since I'm subtracting 5 from x, I know it's going to move left 5 units. And then since I'm adding 7 to the y coordinate, I'm going to move up 7 units. Okay, so we're going to go left 5 units, up 7 units for each one of these points that we have. So now what we're going to do is find where those are located, and we're going to write the coordinates of A, B, C, and D, call them A prime, B prime, C prime, D prime, and we're going to give their coordinates. So let's start with point A. Point A is right here. I'm going to go left 5 and then up 7. Left 5, 1, 2, 3, 4, 5, up 7. 1, 2, 3, 4, 5, 6, 7. Right here is point A prime, and it's located at 1, 3. 1, 3. Okay, and that makes sense because if I take A's coordinate, x coordinate, 6 minus 5, that gets me the 1. And if I take A's y coordinate, negative 4, and add 7, I'm going to get positive 3. So A prime is at 1 comma 3. B prime. All right, well, point B is right here. Let's go left 5. 1, 2, 3, 4, 5. Up 7. 1, 2, 3, 4, 5, 6, 7. Right here. Point B prime is at 1, 1. Now we're going to translate point C to C prime. So here's point C. Go left 5. 1, 2, 3, 4, 5. Up 7. 1, 2, 3, 4, 5, 6, 7. Right here is point C prime. And it's located at negative 1, 2, 3, positive 1, negative 3, positive 1. And finally, point D is right here. We need to get to D prime by going left 5, 1, 2, 3, 4, 5, up 7, 1, 2, 3, 4, 5, 6, 7. Right here is point D prime, and that's located at negative 3, positive 3, negative 3, 3. So let's go ahead and connect these points to create the image A prime, B prime, C prime, D prime. And it will look something like this right here. Okay, so there's our image, A prime, B prime, C prime, D prime. And again, this was our pre-image A, B, C, D. All right, question D says, make a comparison about the rectangles A, B, C, D and A prime, B prime, C prime, D prime. How do the image and pre-image compare to each other? Well, we can say that the rectangles are congruent. The rectangles are congruent, meaning that they're the same shape, they're both still rectangles, and they're the same size. All right, you could count from D to A, 1, 2, 3, 4. Count from D prime to A prime, 1, 2, 3, 4. And then from B prime up to A is 1, 2. From B to A is 1, 2. They're the same shape, same size, so they are congruent. And the orientation is preserved. Okay, the rectangles are congruent and the orientation is preserved, meaning that the letter ordering stayed the same. If we look at our pre-image A, B, C, D, and then our pre-image A prime, B prime, C prime, D prime, the order of the letters stayed the same. So the rectangles were congruent and the orientation was preserved. In our final example, we're going to translate a triangle this time, triangle FYI. Let's first plot where that triangle is located. F is at the origin, 0, 0. Y is at 0, 3, so 3 units up from the origin. And I is at 2, 0, 2 units to the right of the origin. F, Y, and I. So let's go ahead and connect those. Okay, and this is going to be a right triangle. When I plot all of my points here and connect them, there we have it. Okay, we have a right triangle, all right, FYI. What we're going to do is predict how the rectangle will be transformed following our next rule. Okay, so again, this is going to be translation. We're doing x plus 3, which means that we're going to move our triangle right 3 units. And then y minus 4 means we're going to move our triangle down 4 units. So we're going to translate each unit or each point rather, right 3 units and then down 4 units. So let's start with f and figure out what the coordinates of f prime are going to be. Go to the right 3, 1, 2, 3, and then down 4, 1, 2, 3, 4. Right here is point f prime, and it's located at 1, 2, 3, 1, 2, 3, negative 4, 3, comma, negative 4. Point y now to get to y prime, we're again going to go right 3, 1, 2, 3, down 4, 1, 2, 3, 4, right here. And that is point y prime. And it's located at 1, 2, 3, comma, negative 1, 3, negative 1. And finally, I prime. So here's point I, go to the right 3, 1, 2, 3, and then down 4, 1, 2, 3, 4. Now we're at 5, comma, negative 4, 5, comma, negative 4. So let's plot, or we've already plotted. Let's go ahead and connect the points that we plotted with our ruler. And then we will be able to see our new triangle. All right, f prime, y prime, I prime. And there we have it. There's our new triangle. And so once again, make a comparison about your two triangles, all right? Your pre-image, FYI, and the image, F prime, Y prime, I prime, all right? These two triangles are congruent. The triangles are congruent. They're the same size. They're both still they're both the same shape, I should say. They're both still triangles, and they are the same size. So the triangles are congruent. And once again, the orientation is preserved. The orientation is preserved, meaning, again, that our letters are going in the same order. F, Y, I, F prime, Y prime, I prime. So the triangles are congruent and the orientation was preserved under this translation.